not, air, this JPL is air's territory kind of thing. So it was a real problem. It was very hard for us to get funding because he was the chief scientist. In fact, various people tried and they said they'd never seen him respond like that to anything else. But like I said, John Ayer thought it was great. So, and then a lot of my thesis work at Caltech was on the accuracy because people were questioning. So this is the last stuff. I put that shutting the AS off. I didn't know how that happened. I was sort of wondering, but it was what Tom said about Topex. But that was amazing that JPL somehow was able to get the Air Force to shut off that. I'll just make these quick points. GPS MET demonstrated that RO could be done on the Earth with GPS, using GPS as sources. It demonstrated this unique and very powerful combination of very high vertical resolution, precision, and accuracy with global coverage. And then from my standpoint, the key thing about COSMIC was it demonstrated it could, with 6 satellites, you could do it operationally and have real impact on NWP. And I'll just mention, I remember when Sean Healy told me when he turned on the COSMIC data the first time, I forgot to put this in here. What happened was the aircraft bias, temperature bias shifted. And Sean's response was, what the hell have I done wrong? And then the aircraft people came down the hall going, this is his description, they came down the hall going, how did you find the aircraft bias, the temperature bias? And then Sean explained it, and it's like, and that was when COSMIC really took off, because once people saw that correction, they went, oh my God, this is real. So anyway, that's it. That's it.
Okay, we all heard very interesting histories, and now I would like to invite the following individual who was key player in the GPS MET to be joining us on a panel that include Bill Shreiner, Sergey Sokolovskiy, Chris Rocken, Doug Hunt, Bill Randel, and Tom Meehan. Thank you. Please come to the front. Thank you. Well, as they settle in, we very much appreciate it was a great team effort and also strong collaboration from multiple institutions to make the GPS work. And I would like to, at this time, introduce our panelists. And I would like to start by introducing yourself and also talk about what was your role in GPS MET, and then anything you want to share with the audience here, the good and the bad and the ugly, and also what was really your most profound memory in participating in this project. I'll start with Bill Shreiner, please. Thank you. You can push the button and it will, I think you have to hold it. I think you have to hold it.
Thanks, Bill. Hi, I'm Bill Shreiner. And I started at UCAR in 1993, about in the summertime, I remember. And I was hired by Mike Exner to work on the GPS MET project. I had no idea what it was. And my job was to do precise orbit determination and excess phase processing for the mission. And that was an amazing experience. You know, there were very few of us actually in the group. I mean, key people like Doug and Mike was huge in driving this effort. I don't think I've ever met anyone more committed. So I think one of the things I appreciate most was working with all these people that were so committed. And Rick pointed out the chances and the luck that we had along the way. And if it wasn't for all of these people just working so hard to the bone, you know, this wouldn't have happened. And then COSMIC came along, and I was involved in designing the 8 or 6 satellites. It was originally 8. And we got a constellation. We knew we needed global coverage. We didn't have the refresh maybe we wanted, but and then that was an amazing success. And then we wrote it into Cosmic 2. I'm skipping all of the hard parts. But then Cosmic 2 was an amazing success as well and still is going. And after launch, I had to make a change because the mission did take it out of me, actually. And I needed a break. And so I did. I stepped away. And I'm glad I did. It gave opportunities to other people, but gave me a chance to recover from it was a long period of time of working really hard to make this stuff work. So that's about all I have to say. But
Yeah, I also want to comment that Bill was actually the cosmic director from 2016 until like 2021, right? Yeah. So again, thank you for your great leadership. Meehan, what you wanted to share?
Sure. Thanks. Thanks, Bill. I feel like I've been sharing a lot already. I'm going to first share a story about Bill early on. I'm sure you remember this. I mentioned sort of the contention between JPL and UCAR. I recall, I think Bill somehow downloaded the JPL POD software. Maybe he was part of a class or something, and somebody somewhere noticed that it had gotten downloaded from somebody at UCAR, and I think you heard from JPL's lawyers. Yeah. How terrifying was that? Okay. So anyway, I just remember that when he said when he showed up. Look, I was part initially, as I mentioned, I was the project manager for the turbo receiver as well as the rogue receiver, but that became the GPS Met instrument, and then later the Blackjack, which became the Cosmic 1 instrument. And then later, I was not project manager for the trig. I was just worked out the design stuff and the software. I guess if I had to say, aside from the things that Bill covered, obviously I appreciate the personal interactions that we've had. I appreciate the history, the fact that I think everybody in here did something impactful, and it's nice to be part of that. I also appreciate how much better I think things are now. A lot of the contention, I think, had to do with just getting a ride on a spacecraft was a ridiculously big challenge. I mean, I see a lot of fresh-faced people here who I'm sure you understand. I mean, my view is right now you step out on the curb with an app on your phone and you have an instrument that you want to put in space, and then you hail a CubeSat, and then you plug you plug your device into the CubeSat, you go back to your office, have a cup of coffee, and then download data that has just been launched. That's how it works now, pretty much, I think. But it was a lot different back in the old days. So I appreciate how far we've come. I really appreciate this community. I've always said it's axiomatic that the bandwidth of your research is inversely proportional to your success, because I was doing all kinds of stuff in the early 90s, all kinds of directions, and then RO showed up. It was very successful, and that's basically all I've done since then for the most part. And it's not necessarily a bad thing. It's just something to be aware of. That's all I have. Thanks.
Thank you, Tom. I also say that we would not be able to do the GPS Met or Cosmic 2 without Tom's hard work and leadership in the receiver and radio quotation development at JPL. Well, thank you, Tom, for doing all that. Next, please, Dr. You have to hold it.
You got to press it and hold it.
You have to hold it.
Oh, you got to keep on holding it.
Yeah. You got it?
I got it. I'm on top of this. So, yeah, my name's Doug Hunt. I was very junior, being hired on with GPS Met in the fall of 1994 as a student assistant. A little closer.
Yeah.
And lean on the button at the same time. And so I knew nothing about the science or the history of this whole thing. What I did know was software engineering. I was a refugee, an escapee from IBM Federal Systems, which is not a place I'd recommend working if I And so I escaped to UCAR. I was willing to take a humongous pay cut just to have, be out of classified work and to be able to have some life, and so I remember my idea was to instill some software discipline and beauty on the ground processing end and just figure out how to get all these data and how to get it all to flow and how to get everything to be pretty and nicely organized. That was my main thrust at the time. And I've been catching up on the science ever since. I remember at one point we had got an interesting vision in my head of we were all in our FL4 building across the street, and GPS Met had just been launched. This was maybe, a week after launch or something like that. And there was somehow a camera crew inside. We were in this big room, this communal area, all sitting at our computers. And I was writing the code to generate a plot of a comparison between radio occultation, the GPS Met results, and radio sonde. I was, pulling data in, and, this was before you had beautiful Python scripts to generate all these world-class plots. We had very basic software. And I finally got this thing up on the screen, and they, the camera guy came past and, gave a quick photo shot of this thing. And that somehow got melded into some video or other, a 2-second cut later on. But that was my, I don't know, kind of dynamic impression of this whole thing. And going forward to Cosmic 1 and Cosmic 2, like I think Chris Rocken had said earlier, it was month in, month out, or day in and day out. We had a frowny face for Cosmic 1 or a smiley face, depending on what they said on the last trip back from Taiwan. So it was quite a roller coaster. And we were always, we always had funding a month out or something. And okay, now we've got another injection of funding. Somebody's given us $2,000. We can keep the lights on or something. So it was a little bit stressful. But I remember at one point, Mike Exner talking to me saying, we can get this Cosmic 1 funded. That'll build a career. And by golly, he was right. It was so it's been a great ride. It's been very interesting, beautiful people to work with, all very smart, generally very kind. And so it's been a very nice thing. And I appreciate the opportunity to have worked in this.
Thank you, Doug. As you know, many of you download data from CDEC, and he's the person who really is the software architecture for the entire data processing system, ever since start GPS Med and through Cosmic 2. Thank you, Doug, for all your tremendous amount of leadership and hard work in making CDEC really work. Next, we have Sergey Sokolovskiy.
Yeah, my name is Sergey Sokolovskiy, and I started working together with Bill Shreiner and Doug Hunt in '95 as a visiting scientist. Years later, actually, I got permanent position, and I was working on the neutral atmospheric conversions at first, then on the ionospheric conversions, and on multiple other things. And I consider myself lucky to work in such a team of great people devoted to their work and very nice. And I wouldn't list them because they're all present here, maybe except Mike Exner. Yeah, so I'm just very grateful that I had this ability to work for years in such a team. Just one very quick comment. Mike Exner was also very devoted to his work. Rick mentioned, I forgot who had license plate on his car, GPS Met, yeah? Mike Exner also had license plate, GPS Met on Ford Explorer. Yeah.
Okay, well, Sergey certainly has been the soul for the entire UCAR's radio quotation history, in terms of GPS Med, Cosmic, and Cosmic 2. I could not find anybody who is more knowledgeable in terms of radio occultation, who is more humble. And you can always talk to him, and he always give you straight answers. But one thing I want to caution you is that sometimes you should not joke too much with him, because he takes it seriously. One time, I don't know, maybe 10 years ago, somehow we have at Anchor site, we had a snow pool, and I was lucky to guess the right first day of snow. And I was going to buy some bagels and treat everybody. So I wrote an email to everybody in Cosmic saying, well, guess what, guys? I was able to use Cosmic data, and I was able to predict the first day of snow in 2 months ahead. And you know what? 5 minutes later, Sergey rushed to my office. Bill, how did you do it? How did you do it? I fell off my chair. Speechless. Thank you, Sergey, for all the years of scientific and leadership. As you know, in 1992, as when Rick asked me to join GPS Med, I know nothing about GPS Med. And it is Sergey who taught me, so that I get to know a little bit about radio occultation. Thank you, Sergey. Chris Rock. Yep.
Thank you, Bill.
My name is Chris Rocken, and I used to be chief scientist for Cosmic, and then when Cosmic 2 started, I moved on to do something else with my life. But today I'm going to reminisce a little bit on the really early day. I mean, we went with Rob, already went way back. I'm going to start on the question why Stick Ware, who wrote the GPS Met, the original GPS Met proposal, why did he do that as part of the UCAR? And especially since he was, by that time, he was the head director of UNAFCO, University NAFTA Consortium, which I was the chief scientist of UNAFCO when that proposal was written. And this all goes, UNAFCO, most of you probably won't know it, it's a consortium of universities, initially CU Boulder and Harvard, Princeton, Columbia, Stanford, were the original members that combined one proposal to start buying really early GPS receivers. At that time, they cost $100,000 a piece. And we wanted to use those receivers for measuring tectonic motion, plate motion, plate tectonics. So it was all the earth science departments from these universities that came together. None of them could afford the receivers. And so that proposal was written, it was funded, we bought GPS receivers, but we soon, right away, realized that one of the limiting error sources was the Earth's atmosphere delay. So out of that, of the desire to measure plate tectonics, came then the effort, what do we do about the atmosphere? And we dealt with it with measurements, water vapor radiometers that were even more expensive than the GPS receivers. But then several GPS software packages started developing methods how to estimate the tropospheric delay as a noise source for positioning. So, and then Mike Beavis later on realized, oh, this is not just a noise source. You can also use this tropospheric delay due to water vapor as data for weather research. And that's how UNAFCO, which was really a geodetic earth science organization, started getting interested in atmospheric science. And then Stick started talking to Rick. The scientists started coming to Boulder, like Lydia Kukurul came here because she was interested in that application of GPS, the estimation of atmospheric water vapor. And so this is how it came about that UNAFCO moved out of CU into UCAR. And at that point, and I thought it was great too, because I was interested in atmospheric water vapor. I started chasing Bill Kuo around the cafeteria, tried to get him interested in the ground-based at that point still, ground-based estimation of water vapor. But the whole history of the geodetic applications that was one reason why, for example, Rick showed the first profile of GPS Met after the launch, that we could produce, we at UCAR could produce a profile that quickly, was because in the geodetic sciences, we started out having GPS receivers that could only be moved by donkeys into the field to where we wanted to measure tectonic motion. And so the GPS receivers were huge, and then there was pressure on people like Meehan and private industry. Trimble, Ashtec were the companies that competed with what JPL was doing, and pressure to reduce the volume and the mass of these receivers. So the receivers were reduced in size, came down to something that finally could be launched on GPS Met. The software was pushed also in large part by the earth science community's desire for more and more accurate positioning. And we started out with what's called one ppm, which is 1 centimeter per 10-kilometer error in positioning, which is now down to parts per billion. And a big push was made, especially for orbit improvement, POD of the GPS satellites, and other algorithmic improvements. It was done at JPL by I don't remember all the names, Willy Berdicher, and then the group with Tony Minucci was also involved. And so basically the science was pushed to a level that GPS Met was possible in large part, not only by what was done at Stanford and Caltech for atmospheric sounding, but also by the earth science community. So it's a good example that there's interdisciplinary work, and stickware talking to Rick Anthes can lead to great things. So it's good for all of us to talk to other disciplines from time to time. Yeah, and then GPS Met started, and my first task there was to convince Mike Exner that he said, we don't need any orbit determination, or we don't need any POD, because GPS, the broadcast message, has all that information in it. I said, no, not quite good enough, not good enough by a long shot. And that's when we hired Bill Shreiner to take that task on, and Doug Hunt to, as he said, to discipline us with how the data should be processed. The first time I heard about databases at that point, it was all new. But so that's how GPS Met got going. It was stickware, Rick Anthes, interdisciplinary, but the whole history of UNAFCO. Then I don't want to talk too long, but I was quoted here several times about the 1 month Cosmic would die. 1 month it looked great. Another month we were sued again by orbital scientists because, as we called it back then, they tried to patent gravity. And yeah, it was, they really wanted, they did patent the technique that's used for Cosmic to spread out the orbits in orbit by putting them at different altitudes. Differential precession orbital did patent, and UCAR wasn't willing to risk a fight with orbital. That's why we ended up doing Cosmic with orbital in the end. Otherwise, there were other ways we could have done it. But anyway, so it went up and down, and one of these down phases, Chris McCormick and I said, "Screw it, we're not working today. We're going skiing." And so we drove up to I don't know, was it Copper or Winter Park? Winter Park, and we skied a little bit, but then we got I don't know. We went to the bar midday at the ski area. We sat at the ski area bar and told, there wasn't much going on. And we told the bartender our sob story, you know, how we've worked day and night to get this mission off the ground, but now it was finally dead because maybe this was the patent issue or a bad news from Taiwan. I don't know what it was. But so after a few beers, we were ready to pay, and the bartender had pity on us. He said, "You guys are in such bad trouble, you can have the drinks for free," which is very remarkable for ski area bars, but we must have been in dire straits. Anyway, Cosmic then started happening. It was a great success, and I'm And it's been a great ride, the whole period of GPS coming from donkey carried receivers to now Cosmic 2, and I'm so grateful for all the great people I worked with, and grateful that we have overcome many of the competitions between UCAR and JPL that shaded our collaboration in the early days. And I want to thank all of you, and I'm so happy to see, since I'm not in this field anymore, so happy to see so many faces that I know from way back, and new faces. So it was a great ride, and keep up the good work.
Well, thank you, Chris. As you know, doing GPS Med, doing Cosmic, you really need somebody who can connect from the engineering side to the science side to software, aspect. And Chris was the manager of CTEC and also the chip scientist. I'm convinced we would not be able to do Cosmic and GPS Net without somebody like Chris, who's connecting everything together. And he's also able to connect to the science application and reaching out to the community. And again, thank you, Chris, for your many, many years of contribution to GPS Med and Cosmic. Next, Bill Randel.
Hi, I'm Bill Randel, and I'm a scientist at NCAR, and I'm also have a part appointment in Cosmic these days. And so I'm different from all these guys. I was not involved with GPS Met and building it, or I'm not an engineer. I'm a more atmospheric dynamics person. And so my introduction to this field was listening to Rick Anthony's give a seminar probably at NCAR. This is probably like 1997 or something. And he gave a really nice talk, like Rick always does. But I remember at the end, and he showed how this was going to work. And I remember thinking, well, I'd be like the reviewers for the NSF proposal. It's a really kind of clever and cool idea, but it's probably not going to work. And there's all these details that aren't going to work. But it happened that summer. I had a so-called SOAR student, so a young student at NCAR. They have a program. And I had a student that summer, and I put her to work on looking at GPS Met data, and we compared with radiosondes, and I convinced by the end of the summer that GPS radio occultation data was really beautiful data, and we ended up writing a nice paper. And this person went on to have a career in science, and she's a teacher. But anyway, from ever that time, so that's 30 years ago basically, and I've been kind of a fan of the data. So I'm a data analyst, and I'm a fan of the data, and you all know, and we'll hear this week of the great applications and the growing climate record, the dense data that we have now available. So I've stayed involved and really interested. I've had dozen students over the year write papers and theses on GPS things. I want to echo what people say about the people within Cosmic, but in our whole field, and it's very collegial, and I know many of the people here. But it's a great field, and it's kind of open-ended. Gosh, I see the Chinese person today said we're going to have 150,000 occultations per day in 2 years from now. It's just amazing what things we're going to do possibly with these data. And so that's my involvement.
Okay. Well, thank you. Bill has been a NCAR senior scientist. And he also was a director of an NCAR lab. And remember, in the early days of GPS Med and Cosmic, there's actually many people within NCAR who does not believe this technology. And many people even tell me that this would never work. And I would just say, having Bill, having such a great scientific credential, he's a climate scientist, and he's willingness to work on the GPS Med radio occultation data and show that it really has an impact on the science. It's really, really critical for us to continue to move this forward. Thank you. And he's actually still very, very active, still helping students and postdoc, and we're very grateful for what he has been doing for us. Yeah, please. And in the push.
I meant to say this before. One thing that I thought of when Rick said that luck is a big part of all this, the even the big picture political situation when GPS Met started, that the fact that so many Russian scientists were looking for new funding because of what was going on in their country. The fact that we at that point, through contacts that Rick and Bob Serafin had to Russia, that our young GPS Met program could hire at the same time Sergey Sokolovskiy and Mikhail Gorbanov. It's like a startup soccer team hiring Ronaldo and Messi, you know. We could have never competed seriously with Rob and JPL at that time. They were ahead, even though Ben Herman and Dong Feng had Dasun had written great software for the initial inversions. The whole thrust to deal with multipath in the observations and ducting situations. These guys, I was really lucky that they could join our team that early. I was just going to add that.
Thank you. So it is time for you to ask questions to the panelists, if you have one. Please feel free. While you are thinking about the questions, I wanted to, comment on the lock. I still remember this like maybe about a month before the launch of Cosmic, and we are already all excited about the launch because we've been working on this for many years, and there's already some people already going to the launch site, prepare for the launch. And then all of a sudden we got an engineering analysis to say, Bill, I think we got a problem. What do you mean? What problem? Say, well, we're going to be releasing 6 satellites, one after the other. And we're using the sprint to launch one after the other, all these satellites. And the analysis say that there is a chance that the speed of the second one is going to go faster, stronger, and could hit the first one. So you may lose both satellites at the same time. And I said, well, so what more analysis we need to do? How much it's going to take to analyze and redesign the sprint to make sure we will be okay with that? And we analyze it, say, my God, all the people are already at the launch site. It's costing us like a couple $100K a year, a day. And waited for a month, it's going to cost several $1 million. We don't have that money. So we said, well, how much chance is that going to be really that happening? Oh, I don't know, maybe 10,000, 1 out of 10,000. And we look at each other, well, let's take a chance. Because we cannot afford it. So after the launch, well, guess what? We actually find the second satellite was ahead of the first one. Luckily, it did not hit. So I'm going to tell you that indeed, there's a lot of luck involved in this mission. It's kind of interesting, right? Any questions for? Yes, please, Ben. Oh, please speak to the microphone.
Yeah, this is Ben Ho from NOAA, and also I want to say it's my honor actually work with you guys for the 17 years that experienced so many things, and I just want to know, for those dark days, you actually know your chances are not very high, right? And then he repeat so many times. You need to have probably I would say 7 miracles in the same time to survive and to continue. And mentioned several times, maybe this is the last month. So how do you go through that beside luck? Is that your faith? Or you just say, forget about it. My career is to stick with this. What actually you are thinking?
Anybody want to respond to that? While you're thinking, I'll say mine. I really believe this mission is going to bring a lot of good to both Taiwan and the United States, and also internationally. And even though it's really hard, but I wanted to do the best I can. There's you know 4 words in 8 words in Chinese. It says 尽其在我，问心无愧. So I want to do my best. If I cannot make it, I have no regret. So I really try hard to make sure that we did everything possible to keep it alive. Thank you. So
Before I ask question, I would like to make a comment. So when I went through Rick's presentations, I saw my supervisor in the picture. Of course, when she was young, she is Xiaolei Zhou, one of the person working on the GPS mat. And she went to Florida State. And my dissertation was using GPS mat and trap. So I feel a few months ago, we had Romex workshop. And I said, hey, Rick, you are the father of Romex. But after seeing all this history, I said I was wrong. It's the grandfather of RO. And all of you, not because of age, but because what you have done to this community. And I feel, you know, this, what you have done, it goes beyond one generation, it goes beyond generations. And maybe I'm 2nd or 3rd generation already. So I really appreciate what you have done. And we have seen the impacts in the NWP, and we are going to space weather, we are going to climate. I just feel I'm honored to work with all of you since then. So my question is, many years ago, you had difficulties to get fundings, and now there are commercial coming up, but we also see that there's also other data types coming up to compete the same pool of fundings. What's your response to that current financial situation to sustain the RO, you know, or similar missions in the future?
anybody want to respond?
Well, since I'm currently not working for the government anymore, but consulting for a private company, maybe your question wasn't addressed to me, but I would always think that government science and government research should always be focused on the cutting edge, pushing the accuracy, developing new techniques, and not worry too much about private companies taking over the routine generation of 150,000 profiles a day, even though that is clearly a concern for US companies, I would think. But I mean, I've always been, also back to Ben's question, I've always been very optimistic about the future, and I was never too worried about maybe other opportunities coming up. And I think for smart people like this, there will be something else to do.
I couldn't agree more than Chris Rocken. And I think, you know, to me, I think our field here, we should not worry about the commercial. I think they were taking the existing technology to make more, but we should be pioneering the technology. We still have problems. Let's face it, we still have problem in the lower part of the troposphere. We still have issues about ionospheric corrections that, you know, why can't we push it up to be more valuable all the way to 50 or 60 kilometers? And also, I wanted to point out too, is we have polarimetric radio occultation. It's basically, we barely scratched the surface. I think we ought to be thinking about how we can doing better, paving new ways so that we can continue to advance the fields. At this time, I would like to invite a few people from the audience who were key players in this GPS Med and Cosmic arena. So first, I want to invite Jeff Reeves, who's in the audience. Would you be interested in coming and say a few words about your involvement in Cosmic and how, and your thoughts, your reflection? And next, I'm going to ask Chris McCormick. Give you 3 minutes only.
Well, I'm scheduled to give a talk on my role in Cosmic after the break.
Okay.
So I'll try to keep this brief. But once we discovered that we could fund this mission, that we found an agency in Taiwan who was willing to provide $80 million, 80% of the cost of the mission. we realized that there was not a good mechanism for getting that funding from Taiwan to UCAR because of governmental restrictions and the differences in the culture and the legal framework between the United States and Taiwan. So we had to get really creative. I won't go into all the details because I actually, for my talk, I started putting together a presentation and listing all of the various contracts and agreements that we had and the different iterations and the obstacles that we faced with patent challenges and et cetera. And I wound up with about 23 slides. And I thought that that was going to be a bit much. So I abandoned that approach. And so for me, being part of the team, coming from the legal, administrative, contractual side of things, where you normally expect a guy like me to be in an office with my horns and my spear, but Rick made me a part of the team, and I think it really facilitated those times when Chris thought I was about to kill the program. We came up with a solution that was going to get us back on track and get moving. And so I felt very fortunate that I was able to work with this distinguished group of people to make this mission possible.
Thank you, Jeff. I know you guys all write proposals, right? And when you write proposals, and you have to go through the budget, and up to date paying your student salary, including travel, computer, and then toward the end, there's a 1 line says overhead, and that overhead could be 50%, 70%, whatever. Every time I write a proposal, I feel I got ripped off. But what do they do for us, right? They're charging us 60%. What do they do for us? I would just say that Jeff was the first time I feel I get my money worth. And now I'd like to invite Chris McCormick.
Yeah, thank you.
Yeah,
for
please
working
tell
all you
us who you
guys.
are and explain to me who you are.
Thanks for working with you guys. It's certainly a pleasure. I've always in my career, I was looking at being a part of a team that helps create knowledge. Not, certainly working for a Google or something to find out a better way to do a advertisement or something. And what Rick said before about not letting older technologies or older knowledge drive you and trying to get newer stuff. It was always interesting to say, hey, this is really new. Let's go make it happen. And what Chris Rocken and Bill Kuo had said before, yes, 1 month we all had smiles and other months we didn't. I flew over to Taiwan 20 some odd times. One time was with negotiations to talk to Taiwan, and certainly Bill was having much more interface negotiating with them with that tech bro lady also. And we flew in at night, went to the hotel, get up in the morning, go to NSPO, and things were going downhill really quick. It was almost noon. Bill said, screw it, we're going to the airport. So we're in Taiwan like 24 hours and we're flying back, to Denver. And it's like, we just gotta leave. That's part of the negotiation tactic, I guess. But this is also one of those things that you're really with all the A+ people who you can trust. And that doesn't happen all the time. And I won't try to do any dig on orbital sciences because I could not trust them. That's a different story. But it was one of those things that the 1 month that we were all over in Taiwan and we're all smiles, and I am not a karaoke singer, and I call it tapioca, but karaoke. But a lot of the time Taiwanese are very much into the singing. So we go to one of those bars, and my total statement was generally, it's not late enough, I'm not drunk enough, and I'm not far enough out of town. So here we are drinking a lot. It's after midnight and I'm in Taiwan. So I get Jeff Reeves with me since he could sing better. And in the whole book, you know, there's a bunch of Taiwanese music. And then there's a bunch of American, Frank Sinatra type stuff, John Denver kind of stuff. And then there's Guantanamera. So here I am with Jeff singing Guantanamera in Spanish in Taiwan after midnight, after drinking a lot. So it was really great. It was better than Chris Rocken and I sitting at the bar doing our sad story and having the bartender say, "Oh, that's the saddest thing I've heard all year." You know, you drink for free. So it was great. So love working with you, Rick. The rest of you guys, working with the international community on the science side. It's a huge pleasure. So thank you very much.
Thank you, Chris. Chris was really one of the most incredible system engineers and incredibly honest, and really enjoy working with Chris. At this time, I want to open anyone who wanted to make comments from the audience. Yes, please, Jennifer.
I'm going to reflect a little bit and then ask a question. I really appreciate Chris's mention of the close link with the Solid Earth community and his reflections back to UNAVCO, which was, as he said, responsible for kind of initiating a lot of the very high precision GPS analysis that's required for RO. And I have to say, I bet you don't remember, but I went out to UNAVCO for training when I was a grad student prior to doing some field experiments. And you were one of the people training us to level a tripod. Another experience was also lugging a van full of, I don't know, 1,000 pounds of TI 4100 equipment out to San Clemente Island with Christine Larson. And there were only 4 satellites up at the time, 4 GPS satellites up at the time. And so there was only a certain time, there was only a certain time of day when you could have 4 satellites up in view at the same time. And it happened to be between 2 and 4 in the morning. And so we had to wake up and put a cassette deck into the TI 4100 at 2 in the morning. And then the worst part was we had to go through this ridiculous procedure of pulling out a meteorological instrument and taking the wet bulb temperature, like someone was ever going to use it to make a tropospheric correction to the GPS data analysis. So that was all fun. And then, so skipping forward that other part of this, Chris was really involved in GPS MET, the other GPS MET, right? The ground-based GPS MET. And I think we learned a lot from ground-based GPS MET. We learned, what level of precision you need to really have. And another important thing we learned from the ground-based GPS MET was how to interact with our meteorological colleagues. And so I remember being involved in a project with 3 labs in Europe that were meteorologists and 3 labs in Europe that were geodynamics tectonicists running the networks. And one of the reason they were so interested in it, GPS MET, was because it was at the very beginning of variational data assimilation. So they practiced with an eye on this bigger prize of the RO, and that was with the Danish Meteorological Institution, and that was at the very beginning. So I appreciate the role that DMI really punching above their weight in terms of size of their GDP or their country or their surface area, being really involved from the beginning. And so one of the things that I've enjoyed over the years is, and we see it every time this group gets together, is the geodesy nerds and the atmospheric science nerds. And I think it's just kind of magical the way that the 2 groups get together. And also, there's those earth science nerds as well. And my question is to the historians here is, what do you see as being like, and I see Lydia walking in. We were working on that project together in Europe on the ground-based GPS, and Jose Patricio also, and he was doing this crazy thing with the aircraft that maybe that'll work someday. Anyway, so my question to the group is, what do you see as we saw, some of these inflection points in forecasting. What do you see as some of the key inflection points in increasing the diversity of people that came together to create Cosmic Program? Diversity in all respects, fields of science, interests, sectors of the economy, demographics.
I would just thank you, Jennifer. I would just say this from my point of view. I think we need to bring more younger generation scientists, students to come into the field. I think that's going to be a very critical factor. Anybody else to come in?
Just that I think we've done a great job with the source program here, and that's what our goal was all along, is to try to get more and younger people involved.
Oh, please. The last word.
Yeah, I guess, diversity in disciplines, I think this field is already very, very well distributed certainly over all the earth sciences, the oceans, the geodesy, the tectonics, the geophysics, diversity in the pool of young people joining this. Maybe that's what you referred to, but I guess the statistics, at least in the US now, say there are certainly more women entering universities than men, which was very different when I went to grad school. So I think that problem will probably resolve itself, or that if it is a problem, that diversity will certainly increase just with time, I would expect. But
okay, well, thank you. Well, let's give a round of applause to our historians. And Yang, I think you want us to come back at what time?
20-minute break.
Okay, thank you. It's about 3:35, right? Okay.